Okay, in this problem, Kaya buys a $20 phone card. So the phone card has $20 on it. She is charged 0.15 of a dollar or 15 cents per minute. So it is costing her $0.15 for every minute that's passing. So it's a ratio right there for long distance calls. What equation gives the value v left on her card after she makes t minutes of long distance calls? And if in this problem, if the variables v and t are confusing you, try saying the statement with actual numbers. Let me explain what I mean here. So we had two variables v, and that equals value, right, left on the card. That's what v is standing for, and t is standing for minutes of long distance calling. Right, and what do they want to know? Well, they want to know, okay, what equation gives the value v left on her card after she makes t minutes of long distance calls? Well, think about this in terms of numbers, right? You could say, what equation gives the value, leave v out for a moment, left on her card after she makes 10 minutes of long distance calls, or 5 minutes of long distance calls, or 1 minute of long distance calls? There you can kind of see what's going to happen is that, well, the value v is going to be equal to what? Well, v is going to be equal to the $20 she has minus 0.15 per long distance call minute. And that, if that's not intuitively obvious to us, let's set up a table here. So plugging in numbers might help you see what's actually happening, right? So we have v is the value and t is the amount of minutes. So let's say no long distance calls are used. Well, then you have the $20 still on the card. After 1 minute, take 15 cents away, and you have $19.85. After 2 minutes, take another 15 cents away, and you have $19 and what? And 70 cents left on the card. After 3 minutes, you have $19.55 on the card. Right? After 4 minutes, you take another 15 cents away, and you have $19.40. So you can see that in terms of slope, right? Every minute that passes by, another 15 cents is subtracted or taken away. So we subtract, or think of this as a negative slope, right, in this problem, where for each minute we lose 15 cents. So if you wanted to calculate the number of the amount of value lost, you would multiply how many minutes you used by 15 cents and subtract that from 20, which is exactly what we're doing here in the table. Now you always want to think about this in terms of graphs as well. The graph, here you have t, which is independent for time, and v for value. And here at 0 we start, let's say, 5, 10, 15, 20. Up here at 20, $20. After 1 minute, right, the value goes down a slight amount. After 2 minutes, right, it goes down slightly. 3 minutes, 4 minutes, right, and so forth. In fact, the way I just drew the graph right there, the line would be even less steep, right, 0.15, not a very steep line at all. And you can think in terms, if my graph here, this is going by 5, 10, 15, right, you really have to go a long way before you reached $15 left on the card. So let's explore that for a moment. There's a fun question. How long will it take before you reach $15 in value? Well, use your equation, right? So if I'm saying that it's reaching $15 in value, that means v is going to be equal to 15. We just need to know how many minutes it takes to reach that point. So we have 15, plug into our equation, right? The value is 15. 20 minus 0.15 times how many minutes gives you that result. Well, we can solve. I'm going to add 0.15 t to both sides. 0.15 t to both sides. And what this does is gives me 0.15 t plus 15, right? That 15 is right here, and then equals 20. This cancels out. Okay, almost done. So now I subtract 15 from both sides, right? Cancels out, and 5 and 0.15 t equals 5. So we divide both sides by 0.15, right? And that'll give us our answer. So t is equal to 5 divided by 0.15. So 15 hundredths. Let's just talk about that for a moment. If I reduce this, I get 3/20ths. So I'm going to think of this as a fraction. It's just easier for me. 5 divided by 3/20ths equals 5 times the reciprocal, 20 over 3. Oops, 20 over 3. And that's 100 divided by 3, which equals 33 and a third. And that just means t equals 33 and a third to get the value down to 15. So in other words, it would take over 33 minutes before I even reach this point right here. And you can see my slope right here is not nearly enough, right? If this is 1 minute, 2 minute, 3 minute, 4 minute, 5 minute, this is probably about 10 minutes right there. This is 15 minutes. It would take double this length for it to reach all the way down to this. So my slope should be a lot less slight, probably more like this, right? It's decreasing over time, but very slightly. All right, hope this helped.